This topic is about quadrilaterals, how to construct a quadrilateral. So before the construction part of quadrilateral, basically we will see what exactly is a quadrilateral and its various other properties and what are the different types of quadrilaterals we have in mathematics. So we're going to discuss all these things in a step-by-step process. So firstly, let me start with quadrilateral. So the definition of a quadrilateral states that it is a four-sided closed figure. So when I say a four-sided closed figure, say I have something like this. So this is a quadrilateral. So I usually denote the vertices with A, B, C and D. Now in this case, I identify that there are four sides which are closed and there are four angles which are at each corners of the given figure. And there are two different lines which we exclusively join from the opposite sides and are called the diagonals. So these two are called the diagonals. So these are the sides, these are the angles, and these are the diagonals. So a quadrilateral has four sides, four angles and two diagonals. So diagonals are 2 in number, angles are 4 in number, sides are 4 in number. So this is the basic structure of a quadrilateral. Now, one thing I have to note here is all sides may or may not be equal. The first property of a quadrilateral states that all sides may or may not be equal. Similarly, all angles may or may not be equal. It depends on the given conditions. May or may not be equal. The diagonals also may or may not be equal. May not be equal. If they are equal, they are given different names which we're going to see in the next session. So when they're equal, what are the different types of quadrilaterals which we have in mathematics? So before this, let's discuss how the different types of quadrilaterals are constructed. Now there are different types of quadrilaterals in mathematics. The first one to start with is, so what kind of a quadrilateral is a trapezium? A four-sided figure. So there are different types of quadrilaterals. So let's start with the first type of quadrilateral, which is called trapezium, and let's see how the definition states. So a quadrilateral is called a trapezium if one of the pair of sides are parallel. So there must be one pair of sides of the entire quadrilateral which must be parallel. So as I find in this diagram, this pair is parallel to this. So this side is parallel to this. So this is one of the pair which is parallel pair, which makes this called a trapezium. Now identify that this and this are not parallel. So for a trapezium, one pair of sides must be parallel. That is the condition for trapezium. Yes. So this is a quadrilateral which is a trapezium in which one pair of sides are parallel. Next, my second type of quadrilateral is called parallelogram. So a quadrilateral is called a parallelogram if two pairs of sides are parallel. So one pair of sides are parallel is a trapezium, two pairs of sides are parallel is a parallelogram. It has been derived from trapezium, but the other additional condition being that instead of one pair, the two of the pairs of sides must be parallel. So as I find that this is one of the pair which is parallel, and this is also the next pair which is also parallel. So in this case, we get a parallelogram. So I find the definition as two pairs of sides are parallel then that quadrilateral is called parallelogram. Yes, and one more thing which I note as a geometrical property here is that if I draw the diagonals, this is an identified property in parallelogram. If you join the diagonals, this intersection of the diagonals exactly meets at the midpoint. So here it states that diagonals bisect each other. So diagonals bisect each other in case of a parallelogram, where one of the diagonal cuts the other diagonal exactly at the middle point. So this is an identified property in parallelogram, along with its definition, which states that two pairs of sides are parallel and the diagonals bisect each other. Of course, the diagonals are not equal. One of the diagonal will be longer and the other diagonal will be shorter. But the identified mathematical property is that in case of a parallelogram, diagonals bisect each other. So now that we have discussed about a trapezium and a parallelogram, let's also see how they are related. Now, interestingly, I say that every parallelogram is a trapezium, but every trapezium is not a parallelogram, because in case of a parallelogram, two pairs of sides are parallel. In case of a trapezium, one pair of sides is parallel. So every parallelogram can be considered as a trapezium because one of its sides is assumed as parallel. So in that case, every parallelogram is a trapezium, but every trapezium is not a parallelogram. Also identify that in case of parallelogram, when opposite sides are parallel, their sides are also equal, because the parallelity condition proves the equality. So for when opposite sides are parallel, obviously the opposite sides of a parallelogram are also equal. Now, the third type of quadrilateral which I identify after the parallelogram and the trapezium is a rectangle. Now, a rectangle is a quadrilateral which is assumed to be derived from parallelogram with only one additional condition, along with the properties which already satisfied with the parallelogram. So a rectangle is derived from a parallelogram with its opposite sides parallel and equal, with each angle being 90. So the additional property of a parallelogram with each angle being 90 degrees is what makes a quadrilateral called a rectangle. Say if I have the opposite sides are parallel, two pairs of sides are parallel, they are equal, even in a parallelogram they are equal, and each angle is 90 degrees, but in case of a parallelogram, each angle is not 90 degrees, it's other than 90. So if each angle is 90, that is specifically given the name called a rectangle. So 90 degrees is the one additional condition which makes a parallelogram called a rectangle. So each angle, so I have all four properties. Opposite sides are parallel and equal. Each angle is 90 degrees. Then what about the diagonals? What happens to the diagonals? Let's see. The diagonals of a rectangle will be equal and they bisect at the midpoint, same as in parallelogram. But in a parallelogram, the diagonals are not equal, but in case of a rectangle, the diagonals are equal. So when the parallelogram tends to make the diagonals equal, it tends to become a rectangle. So diagonals are equal and bisect each other. They are equal and they bisect exactly at the midpoint. They bisect each other. They cut at the midpoint. So this is how I identify a rectangle. Now when I see the relation, I see that every rectangle is a parallelogram. Because opposite sides, two pairs of sides of a rectangle are parallel and equal as similar to this. The only additional property for rectangle being that each angle is 90. Therefore, there is no restriction in calling a rectangle to be a parallelogram. So every rectangle is a parallelogram, but every parallelogram cannot be called a rectangle until and unless each of its angle becomes 90 degrees. So this is how I relate between a rectangle and a parallelogram. Now next comes the square. We all know what a square is, so let's also see the different properties in a square. So square is a four-sided closed figure which is derived from a rectangle. So a rectangle is derived from a parallelogram, but a square is derived from a rectangle. So this is the continued process of a rectangle. So the only difference between a rectangle and a square is that here the opposite sides are equal, but the rest of the properties are same for a square, but all sides are equal in a square. So if a rectangle to be converted into a square, each of its sides must be equal. So I write the definition as if each side of a rectangle is same, then it becomes a square. So if each side of a rectangle is same, if each of the side is same, then that becomes a square. It's a very most simple definition we can give. So a square is derived from a rectangle with each of its side being equal. So all the four sides are equal and they are parallel. And each angle is 90. And the diagonals bisect and are equal. So all the properties which are holding here would hold here, in the form that in case of a square, opposite sides are parallel, opposite sides are parallel, but here opposite sides are equal in a rectangle, but here all sides are equal. The word all is very important in case of a square, where all sides are equal. Each angle is 90 degrees. Each angle is 90 degrees and diagonals are equal and bisect each other. So the only additional property I find between this and this is that all sides are equal. Each angle is 90 and that four-sided figure becomes a square. So when it comes to the relation, I can say that every square is a rectangle, but every rectangle is not a square, because a rectangle has only opposite sides equal, but a square has all sides equal, thus failing with the case. So my relation is every square can be called a rectangle, but every rectangle cannot be called a square. This cannot be called a square. So that is how we understand the different four-sided figures. Now the next four-sided figure is a rhombus, which we want to discuss now. Now let's see the fifth type of quadrilateral, which is called a rhombus. Now we have seen a trapezium, a parallelogram, a rectangle and a square. Now next is the rhombus. Now rhombus is derived from diagonals. So rhombus is a four-sided quadrilateral, which is derived strictly based on the property which it reflects based on its diagonals. So initially, before I draw the four-sided figure of the shape of a rhombus, I first draw the perpendicular diagonals. So I take the two diagonals which are perpendicular to each other. Now in this case, when I join all here in such a way that all sides are equal, then if all sides are equal and the opposite base are parallel, then this kind of a figure is called a rhombus. But the most important property in a rhombus is that the diagonals are perpendicular. And that's the reason all the diagrams which are drawn with flat base is drawn with a flat diagonal in case of a rhombus. Rhombus is always drawn with this to represent and show that the diagonals are perpendicular to each other. So what makes the difference between a square and a rhombus? A square has all sides equal, a square has opposite sides parallel, but in case of a rhombus, opposite sides, all sides are equal, opposite bases are parallel, but each of the angle is not 90, but the diagonals are at 90, cut at 90. So that makes the difference between a square and a rhombus. So there is a possible figure, a four-sided figure which can be drawn with the diagonals being perpendicular and all sides equal, but each of the angle not being 90 degrees. That is how the property of a rhombus arises. So in case of this, let's write the properties. All sides are equal, as in case of a square. Opposite sides are parallel, as in case of a square. But here the most important property, each diagonals are perpendicular to each other, that is they cut at 90. So the two diagonals are perpendicular to each other. So this is one of the important property which identifies the property of a rhombus. Next, I have to note here that unlike the square, each angle of a rhombus is not 90 degrees. As in case of a square, the rhombus doesn't have each angle to be 90 degrees, but its diagonals cut at 90 degrees. So that is how the changed property differs between a square and a rhombus. Now, can we call a square as a rhombus? The relation. When I take the relation between a square and a rhombus, can we call a square as a rhombus or a rhombus as a square? Neither the square can be called a rhombus nor a rhombus can be called a square, because they differ in their properties, with one being with different properties. And when I take the square, a square doesn't have the diagonals cutting at 90. So that is one property which makes a square cannot be called a rhombus, and a rhombus cannot be called a square, because in a square the diagonals are not perpendicular to each other, each angle is 90, but in a rhombus each angle is not 90 but the diagonals are perpendicular to each other. So neither of the properties are subset of each other. So a square cannot be called a rhombus or a rhombus cannot be called a square. Now the last type of quadrilateral which I identify in mathematics is a kite sort of a shape. So a kite is just like a rhombus but with different properties. As in case of this, I have the diagonals perpendicular to each other, but here all sides are equal, but there all sides are not equal, but one pair are equal. So this is how a kite is represented, where this adjacent sides are equal and the diagonals are perpendicular, but all sides are not equal nor parallel. So I don't find these to be parallel. So this kind of a figure is called a kite. So let's see the last type of quadrilateral, which is called a kite. Now in case of a kite, I identify that it is also a closed four-sided figure in which the quadrilateral has adjacent sides equal, but the diagonals are not perpendicular, nor the opposite sides are parallel, nor each angle is 90 degrees. So in case of a kite, the only property I identify is that adjacent sides are equal. So the two pairs of adjacent sides are equal. You can call them as two pairs of adjacent sides are equal in case of a kite. So this is how I identify the kite. Now when you connect rhombus with a kite, can you call a rhombus as a kite or a kite as a rhombus? Is one of the most important property which you identify. Yes, every rhombus is called a kite because based on the properties of a kite, all the properties of rhombus are satisfied here, which if you understand with adjacent sides equal, here in case of a rhombus, all sides are equal, thus making this to satisfy with adjacent sides being equal. And the condition of diagonal perpendicular to each other doesn't arise in a kite. So whether the diagonals cut at 90 degrees or doesn't cut at 90 degrees doesn't affect a kite. So when I just identify the relation, I identify that every rhombus can be called a kite, but every kite cannot be called a rhombus because it fails in the property. Two of the properties, one being that all sides are not equal in a kite and diagonals doesn't cut at 90 degrees. So a kite cannot be called a rhombus with its own limitations. So this is how all the different types of four-sided figures are identified in case of the topic of quadrilateral. Now, when you have the different types of quadrilaterals with their different respective properties, we should also be able to construct them when specific dimensions are given. If I give few sides and few angles, I should be able to construct using the given dimensions a perfect quadrilateral which is required for that particular dimensions. So we're going to see in the next coming session where we are going to find how we can construct different types of quadrilaterals using the given dimensions, the various possible dimensions. Now let's start with the construction of quadrilaterals. So initially we have seen the different types of quadrilaterals, the types of quadrilaterals based on their respective definitions. Now we'll see how a quadrilateral can be constructed. Before the construction process is understood, the first and foremost thing what I do here is I understand that the construction needs some information for the given quadrilateral which needs to be constructed. So the given dimensions need to be the minimum information which has to be provided so that a perfect quadrilateral can be constructed. It is not necessary that all four sides, all four angles and two different diagonals, all the dimensions are given. Sometimes with the least of the information you can construct the quadrilateral. So the least of the information is provided in 5 different forms, where if I have 4 sides and 1 angle, irrespective of the other 3 angles and the other two diagonals, I can construct a quadrilateral with this condition number 1. Secondly, if I have 4 sides and 1 diagonal, irrespective of none of the angle given and one of the diagonal which is not given, also I can construct a successful quadrilateral with the second condition. If I have 3 sides and 2 diagonals, I can construct a quadrilateral. Though one of the side is missing here and all 4 angles are missing, still a quadrilateral can be constructed with the least of the information of 3 sides and 2 diagonals. Next, if I have 2 sides and 3 angles such that one of the angle is included angle, then also I can construct a quadrilateral. Now the condition here is that one of the angle must be an included angle, in the sense that if this is a side, this is one more side, then this should be the included angle between the sides. So this is called included angle. Angle between S and S. So the angle here is called an included angle. So if I have one included angle between the sides, the 2 sides which are given, and the other 2 angles irrespective of the inclusion, then also a quadrilateral can be constructed. Next, if I have 3 sides such that all the 3 sides have 2 included angles with one pair having 1 included angle each, also a quadrilateral can be constructed. So these are the 5 different least information provided through which a successful quadrilateral can be constructed. So let's see each of the case with few of the example dimensions and see how a quadrilateral can be constructed for this. Now, before this, I would like to give a strict rule which states that whenever a construction is done using a pencil or any other geometrical instruments like a protractor, a compass, a scale, a ruler, the first rule which comes is that you have to first draw the rough sketch and then do the main construction. The first rule is do the rough sketch and then the main construction. So just besides, you can do somewhere with a small rough sketch and then do the main construction just besides that. That's the first rule. The second rule is use a sharper and a darker pencil. The sharpen point should not be blunt and it should not be light. Both are equally important. Use a sharper and a darker pencil. Constructions are very accurate only when you draw them with precise accuracy. So do not overwrite or thicken the lines or points while constructing. So do not overwrite on or thicken the lines. Do not make them thick by just drawing 3 to 4 times and then the whole of the construction goes deviating with accuracy. This is strictly done for maintaining the accuracy. Yes. And the last point is now these are the 4 different rules which I'm going to use while I do the construction process for any constructions I do in mathematics. The first is do the rough sketch and then the main construction. Always we need to do the rough sketch and then followed with the main construction which you're going to do with the exact geometrical instruments for accuracy. Next is we always use a sharper and a darker pencil because this always helps us in accuracy of the construction of a quadrilateral. The third is do not overwrite or thicken the lines or points while constructing. This again is a precautionary measure taken to avoid the accuracy of constructing a quadrilateral. The fourth is use always a white sheet for constructions because white sheet do not have any disturbance in drawing the constructions. We always do them. Usually the constructions are done on the plain sheets because the kind of paper we need to use should not have any lines or rulers. So these are the 4 basic construction rules which you're going to use while constructing a quadrilateral. Now let's start with the first rule of the minimum information. Let's take 4 sides and 1 angle and see how a quadrilateral can be constructed using the condition number 1, which says that 4 sides and 1 angle is the information which would be provided. Now let's take this example problem which includes 4 sides and 1 angle. Now I have to construct a quadrilateral ABCD where the dimension AB is given as 5.5 centimeters and the dimension BC is given as 3.5 centimeters and the dimension CD is given to be 4 centimeters and then the dimension AD is 5 centimeters and angle A is given to be 45 degrees. So using the 4 sides, side 1, side 2, side 3 and side 4 and one of the angle, let's see how a quadrilateral can be constructed. But before we construct a quadrilateral, in case of 4S and 1A property, SSA property, I first identify the angle to be 45 degrees from where the base which includes the angle should always be taken as the base. So let's have a rough sketch. So our construction is always followed by the rough sketch and then the main construction. So let's have a rough sketch where I take the side which includes the angle 45. So A is the angle which includes in this and in this. So I do not take BC and CD as the base. So this is one of the most important property rule in case of SSA property. I take the base which includes angle A. If I give angle C, I would include that side which includes C. So I include either BC or CD as the base. So because here angle A is 45 degrees, I include the side which includes A. So I can take the base as either AB or AD. So let me take the side AB as the base. So in case of this, I take the side AB as the base and take a ruler, and once the ruler is put on the board, we take the measurement as 5.5 centimeters from A to B. Mark the points and then join the line exactly from the ruler with a sharper pencil and a darker pencil. So once I take the base AB through a ruler with the measurement of 5.5 centimeters, I put the protractor at A and then I find the angle from B. Do not take the angle from the left because that gives the wrong angle. You're following the angle from B, so you have to follow from right through the protractor, which gives me approximately somewhere as 45 degrees. So my angle A is 45 degrees through a protractor. So once I take the angle 45 degrees, then from A, I take the measurement of 5 centimeters to D and then cut an arc. So putting the compass at A, pointed at A, I cut an arc in this form so that I get an arc which cuts at D with the measurement 5 centimeters. So my AD is 5 centimeters, which I cut the arc from, and then from B I take the measurement of 3.5 centimeters and cut an arc which would give me C. So let me start with D. So from D I take the measurement of 4 centimeters and cut an arc. So from here let me cut a measurement of 4 centimeters and cut an arc, and then from B let me take the measurement of 3.5 centimeters and cut an arc. So I get the point C, where I join them to get the distance CD, which is obtained as 4 centimeters, and the distance BC, which is obtained as 3.5 centimeters. So this is how I get the quadrilateral ABCD through the construction using a ruler, a pencil, a compass, and a protractor. So let's again recap once more for this problem. Because angle A is given to be 45 degrees, in SSSA property, I take the base which includes angle A. So I can take either AB or AD. So I do not take BC or CD because it does not include angle A. So let me take AB as the base in this case with a measurement of 5.5 centimeters. So first I take a ruler, mark the points from A to B exactly till 5.5 centimeters and join that with a ruler from the end points of A and B, which gives me the measurement as 5.5 centimeters. Then next I construct the angle A, which is 45 degrees, using a protractor. So take a protractor, put it at A. So once I exactly put at A, I just construct an angle of 45 degrees proceeding from B, because the side related to angle A is from B, so it comes from right. If my side is on the left, then the angle comes from left. So because it is from right, I raise it to 45 degrees and then extend the line. So mark 45 and extend this line. So once the line is extended, I take the measurement of AD as 5 centimeters from the compass, take 5 centimeters of length on the scale, put the compass on the point A and cut an arc. So once the arc is cut, I get the length AD. The point where it intersects will be the point D, which is the measurement of 5 centimeters. Then once from D, let me take a measurement of 4 centimeters so that I get the point C from there. So take the compass, point it at D, take the measurement of 4 centimeters on the ruler, then cut an arc. Then you get an arc of 4 centimeters from D. Similarly, put the compass at B, pointed at B, then take the measurement of 3.5 centimeters because BC is 3.5 centimeters and cut an arc so that the two arcs intersect at one point, which is the point C. And the quadrilateral has its dimension BC as 3.5 centimeters and DC as 4, and join each of the coordinates so that you get a quadrilateral ABCD in this manner. And once you understand the rough sketch, then the main construction is done using geometrical instruments. I have done the rough sketch here, and you're going to do the main construction based on these properties using the perfect geometrical instruments. Now, a rhombus is to be constructed. Construct a rhombus MATH where AT is 4 centimeters and angle MAT is 120 degrees. Now, constructing a rhombus math using AT equal to 4 centimeters and one of the angle is 120 degrees is nothing but the properties which we identify in rhombus. Now, a quadrilateral is a rhombus if all sides are equal. So if one of the side is given as 4 centimeters, then I need not worry about the other 3 sides because all sides are equal in a rhombus. So the construction of rhombus using the properties of rhombus is something which very much helps in the construction process. So let's start with a rough sketch. So let's start with a rough sketch where I need to find the properties. So my AT is 4 centimeters, which helps me in taking one of the side. But before that, because my angle A is 120 degrees and my side is 4 centimeters, so directly I can construct using the base as 4 centimeters. And then I take the protractor, put at point A, then I construct using 120 degrees. From T, I start with the protractor, then the angle is an obtuse angle because 120 is more than 90. So I get an obtuse angle, and from A, I would like to construct each of the sides as 4 because in rhombus all sides are equal. So I take the same measurement of 4 centimeters here and cut an arc. I get a point here, and from there I take another measurement of 4, cut an arc, and from here cut an arc. Then I get all sides equal with each one being 4 centimeters and the angle is 120. So I get this MATH is the required rhombus. Now you wanted to know whether the constructed rhombus is correct or wrong. How do you verify that the given construction or the given quadrilateral which you are constructed is a rhombus? We know that the diagonals are perpendicular in a rhombus. They cut at 90 degrees. So just join the diagonals and measure the angle with a protractor. If you get this angle to be 90, then your construction process is correct. If you don't get this angle as 90, that means the whole of the construction which you have done need to be rechecked because somewhere it might have been done with some wrong process. So the verification is check the angle between the diagonals. It should be equal to 90 degrees. Check for the angle between the diagonals. If it is 90 degrees, then the quadrilateral which you have constructed is a perfect rhombus. If it is not 90, then again it needs to be rechecked because the question is about constructing a rhombus. So when one side is given, it is understood that all the other sides are also equal, and with one of the angle as 120, we try to construct the rhombus using these rhombus properties. Yes, let's see the other property which we have seen with the minimum information where 4 sides and one diagonal property, where 4 sides and one of the diagonal is given. So I had to construct a quadrilateral PQRS in case of this problem where each of the dimensions are given. So let's take one of the side as the base and start constructing the other 3 sides and one of the diagonal and then form a complete quadrilateral. So in this case, to follow with the rough sketch, I first take PQ as the base. In this case, I can take any side as the base because I think one of the diagonal can be constructed either way. And I think, yeah, let's take PQ as the base. Then make the measurement of 3.5 centimeters using the ruler. So once the base PQ is taken, then from there, I just construct PS, which is nothing but 4.5 centimeters. So take the measurement of 4.5 centimeters from P and then cut an arc. So I just measure and cut an arc. Then RS and SP. Now QS is one particular side which is the diagonal. So this is identified as the diagonal because in case of SSSD property, you should be able to identify the diagonal in case of all the various dimensions, the 5 dimensions which are given as lengths. So in case of these 5 dimensions, I understand that QS is the diagonal because QS would always be the alternate vertices forming a diagonal. So from Q, I'll take the measurement of 6.5 centimeters and cut an arc so that it cuts somewhere with this. So somewhere like this. So from here, this would be the point S from where I can construct a diagonal. So PS, and join this to get the diagonal QS. So from S, I have the remaining sides which I need to construct, where RS is to be constructed. Therefore, I take the measurement of 5 centimeters, use the compass, put the pointer at S, and take the measurement of 5 centimeters exactly from the ruler and cut an arc so that I get 5 centimeters out here. So I get 5 centimeters distance from here. Then from Q, I also have QR, which is 4 centimeters. So take the measurement of 4 centimeters from the compass using the ruler and then cut an arc so that I get the 4 centimeters from here. So this would give me the point R. So here the quadrilateral PQRS is constructed successfully using the given dimensions for 4 sides and 1 diagonal, which can be done in this process. Now you have to verify each of the measurements, which I've taken as PS is 4.5. So you can verify them after you construct, because sometimes we do mistakes. So rechecking the dimensions of each sides is very important by the end of the problem. So my QS, which is 6.5, should be checked with the ruler with each of its sides, and SR, which is given as 5 centimeters, is this, and RQ is 4 centimeters, which is given out here. So the other diagonal dimension is not required in case of SSD property, as we have seen in this case. So this is how a quadrilateral can be constructed from even the second property of SSD property.